Now, this is for new viewers. I watch a lot of so-called dissident scientists, and rather than reply to them directly, which seems to be inevitably confrontational, I'm just going to ignore that and talk about my own philosophy of nature. Now, this is my system. I'm not saying this is the system of science. However, I do try to limit my ideas uh, to realms that don't contradict the scientific data specifically. The scientific interpretation is fair game. Now, we have two issues I'm going to talk about. First of all, I think you new viewers don't understand that space is in every way a thing. It has qualities. It's not a rock, but neither is a photon, and a photon is also a thing. It's a thing because it has qualities that are contrary to other things or even possible configurations of it. So, for example, space is three dimensions. This is a purely ontological, experiential argument. First argument. It's not two dimensions, it's not one dimension. People call it four dimensional, but that's including time. Extent space, the space of a volume of a physical thing with tactile qualities that you can touch, is three dimensional. Now, we experience it as three dimensions. Just like we experience energies of light as color, who knows, maybe we're translating space into this three dimensions. Doesn't matter. The point is, three dimensions is different from two. It's different from one. Space does have a quality of volume, right? So it's not nothing. If there's nothing in the volume, that would be fine. There would still be a volume. Now, what we know from experiment is that that volume actually always has energy in it, any volume of space. And since it's an extant thing, as materialists, we should assume that there's energy involved in its existence. It can't be made of nothing. Why? Because nothing is made of nothing. Nothing would be no space at all, because space is one of the things that exists in the universe where there isn't nothing. It exists. It is space. It's the medium. It is the realm, the domain in which an object can exist. Space also turns out from experimental physics to have shape and character. To be, it's possible to distort it, which means waves can go through the space. The space has other qualities to it that we've discovered. And I agree with those that say that it's wrong to call these other things dimensions. The magnetic field at a point in space can mathematically be called a dimension, just like time can, but in reality, it's at one of the three-dimensional points of space. And the fact that it's an amount makes it seem like, well, to draw it, you have to draw an arrow, and then you're drawing over other parts of space. Well, yeah, mathematically, you end up wanting to give it its own dimension because it's a free variable. At any given point in space, there is a particular magnetic field and gravitational field and so on. So you have space created from like basically multiple layers, interwoven factors of all the different kinds of quantum field, from the nuclear forces, gravitational, and electromagnetic forces. And the fact that this can be distorted and there can be measurements of this distortion means there can be waves in space, and that's what all of our photons, any potential gravitons, whatever is mediating the strong nuclear and weak nuclear forces, these are all from uh, waves going through the complete, all of the quantum fields, which are not just embedded in space, but literally that is what space consists of. So space is a thing, very important, and now you know. Now, another thing I want to talk about is monopoles. I remember wondering many years ago when they said, "Oh, there's no such thing as a monopole," what they even meant, right? To me, the first question isn't is it correct or not, but what does it even mean? So I'm just going to stick to what it means. Um, Basically, the issue is you can build a machine like a Stern Gerlach um, device, and you can fire a stream of particles or drop them using gravity, but they're usually fired through this device, and it's a pair of um, the ends of magnets oriented so that if it's a neutral particle, it'll just shoot right through. Now, if it has a magnetic field, it will be bent one way or the other. Now, because of the mathematics of this, if you had a purely charged particle that didn't have a north end and a south end, but it was just all negative, it would shoot through and hit a particular place on the screen, right? And if it was neutral, it's just going to hit a particular place on the screen right in the middle, right? And depending on the orientation of the magnet, though, the beam will be deflected left, right, up, or down. Now, you can use a device like this and many other things, basically setting up these fields, such that you can measure the strength of the magnetic pole on the particles that you're sending through. Now, they measure the magnetic field on these candidates for monopoles, and they find that one does exist, right? It doesn't go to that point, but it's bent based on the orientation of the magnetic field. So they've measured that things like the electron and the proton and even the neutron, which has no charge whatsoever, have magnetic fields. So that's something we can see. Now, they call that the spin just because they're trying to think, how can a negative field, a negative particle, have a magnetic field? It should just be a monopole pure negative. But they measure, we see a magnetic field. Well, if you had negative particles like an electron, let's take the electron as a negative particle, if it's going in a loop and they're all negative, that creates an electromagnet, right? So if a ball of charge, the electron's a little tiny ball of charge, and that charge is negative, when it spins around, it's creating a little electrical current. And in the case of the neutron is neutral overall, but inside it has negative and positive quarks. And if those are spinning, it creates a little electric current. And that electric current creates a tiny electromagnet. And so even in the case of these pure monopole style particles that you would want to think are monopole or nonpolar, in the case of a neutron, I don't know if you want to call that monopole having no charge, since charge is involved inside of them, of their construction, and that's moving, that's essentially in motion, it creates electromagnets. Now, it's just a metaphor because nobody thinks the electron, well, some people might think that, I kind of think this way, but the scientists say they don't think that the electron's a little spinning thing and it would have to be spinning too fast and things like this. It's hard to figure out what size it is and do the geometric part of figuring out the size of that electromagnet. But remember, they're measuring on the outside what the strength of that electromagnet is. And they see that it's non-zero. It has a little polar shape, just like any magnet, even though it's just an electron, or it's just a positive proton, or it's a neutral neutron. And they call it spin just because metaphorically that's how you can imagine a pure charge creating a magnetic pole. All right, so that's that. Oh, Quintica, oh, please don't. I hope this isn't a hit job, Quintica. I'm just not into it anymore. Come on. We're old colleagues here. Okay, I'm going to read them. Hey, Piero, I was just heading over to send you a Hubble Deep Field video. I'll post it in your comments when you're done. Oh, that sounds great. This is what I was hoping for when I was hoping not to hope for the other thing. Quintica says Roger Penrose, believes there is some evidence to suggest that there was a universe before the Big Bang. You probably are up on that anyway. Well, thank you for saying that, because no, I wasn't until recently, a few months ago, and I got back into seeing what was up with Penrose, and I found the twister theory, which goes way back, which I had heard of, but I hadn't really understood, and it's that whole idea, and I love it. The idea that the universe just keeps expanding, and then it gets so thin, like space itself is because of the interactions of the particles and stuff. When space gets so thin that that interaction is basically non-existent, or maybe it's impossible, or maybe it's just at some threshold of near impossibility, the size of space and the scale of things doesn't make sense anymore, because the photons, where time is stopped, or however you want to put it, don't care about the size of space. It takes, from their point of view, they go from one particle to another in an instant. Time is meaningless, scale is meaningless, space is meaningless, and so suddenly it's just sort of equivalent to as if everything was in one location again. And so you have the recreation of space and time, and then it just keeps expanding forever, but the scale keeps having a threshold at each Big Bang. And it's pretty crazy. I don't know that I believe it. He has a lot of ideas, like he believes there's sort of a pure Platonic mathematical universe. I do like the ideas. I think they're worth considering. It's hard to know what to make of it. But in this case, I think there might be something to how this abstract math of this concept of, I think it's a topology concept of scale and variance, like an equilateral triangle is the same. It doesn't really matter what size you label the sides with. And so they're indistinguishable. And that there's things like that in mathematics where, this effect that he's talking about could happen mathematically, that might actually correlate to a physical situation. I don't know. I could buy that. I definitely don't like the idea of the Big Bang as we have it. Like, I would prefer a Big Bang that people don't even suggest, but like, it's not really that the universe is expanding. It's more like stuff falls into black holes, gets tunneled back to the beginning of time, and so it's just kind of recycling or whatever. But yeah, the entropy cannot go on forever is one of the problems with that, right? But he's kind of saying, oh, entropy doesn't really matter because there's some. But the whole thing of the scale transition is definitely like hard to impossible to imagine unless you're Penrose. But it is an interesting idea, though. All right, cheers. Nice to have a positive interaction with you, Quintica. I enjoy that. I remember when that used to happen all the time. Okay, cheers.